To start off solving this problem, we'll begin by drawing a picture of Thor swinging his hammer, and he's swinging his hammer at an angle that is 27 degrees to the vertical, so it's a little farther down. And in this case, his wingspan is going to be taken into account as his diameter. So we will be dividing that by 2 later on to get the radius. Right now I'm drawing a closer in image of what forces are on the hammer. There's a force of gravity that's acting down on the hammer, and then a tension force from Thor that is acting at an angle. So the hammer mass is 20 pounds, as told in the problem, and we need to convert this to kilograms so that we can end up getting the answer, which would be what is the centripetal acceleration of Thor's hammer, and this will be written in meters per second, so that's why we need to change it to kilograms. Right now I'm just writing down what we're trying to find so that it can always stay in the mind, and because we have a lot of unit conversion, we need to keep in mind what units we need to convert to so that we can find the proper answer. Because 1 pound is equal to 0.45 kilograms, we'll be multiplying 20 pounds by 0.45 to get 9 kilograms. So 20 pounds is equal to roughly 9 kilograms. And then we also need to find the total radius, so it would be the horizontal component of the tension force, and then half of the wingspan. So to find the horizontal component of the tension force, it would be 17 inches, and 17 inches is the hypotenuse, essentially, of the triangle with the tension force, times sine of 27, so that we can find the horizontal component, plus 18 inches, because it's 6 feet, and then convert that to inches, which would be 36, divided by 2, which is 18 inches. Adding that all up together, it would be 25.718 inches as the total radius. But we need to convert that to meters because our question is calling for meters per second. So the unit conversion there is 1 inch equals around 0.0254 meters. So we would be multiplying 25.718 inches by 0.0254, which gets roughly 0.65 meters. Now for the actual equation. First, I made a sum of forces chart to help us keep track. And there's a positive or upwards tension force, and then there's a negative force of gravity. And then this equals ma, or mass times acceleration. To write it out, I just wrote out the equation. The sum of forces equals ma, and then a can also be written as v squared over r, or velocity squared over radius. So I just converted it there. And then the sum of forces is the tension force minus the force of gravity. So I just put the tension force minus force of gravity equals mv squared over r. After this, I found what the tension force was by plugging in mg for force of gravity, and then ft sine of 63, and got 63 because 90 minus 27 is 63 degrees. And it was Ft sine of 63 because the force of tension that we're using is the vertical force of tension in this case. So Ft equals mg over sine of 63. And then to plug that all back into the equation, I would plug in mg over sine of 63 as f of t, and then because we want the centripetal acceleration, it would actually be the horizontal component, so that is why there's a cosine of 63. And that's all set equal to ma, or essentially mv squared over r. And then we tried to isolate the v by multiplying both sides by r and 1 over m. Several things can be crossed out on both sides, so we did that to make it easier. And then after crossing stuff off and simplifying, we condensed it down to r, or radius, g cosine of 63 all over sine of 63 equals velocity squared. So velocity equals the square root of r times g times cosine of 63 all over sine of 63. And then I plugged in everything that we had found previously, like 0.65 meters into r, 9.8 meters per second for g because he's on Earth, cosine of 63, sine of 63, and all of this is under the square root. After plugging it into the calculator, we got velocity equals 1.802 meters per second. And if you look at the units, it makes sense because inside the square root, it would be m squared over s squared, and then you take the square root and it's m over s. But this problem doesn't ask for velocity, it's asking for the centripetal acceleration. So we have to plug everything into a equals v squared over r. And after plugging it in, we get an acceleration of 4.996 meters per second squared. And that is the answer.